Important test question to find the maximum area of rectangle inscribed in an ellipse. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll understand a very important optimization application test question. In calculus, this is one of the most important topics, and many students find it difficult. We'll not only solve the question, but we'll understand the strategy to solve similar questions. Perfect? So the problem here is related to maximum area for inscribed rectangle. Rectangle is inscribed in an ellipse as shown in the diagram. The question is, find the maximum area of a rectangle that can be inscribed in an ellipse given by the equation 4x squared plus 9y squared equals to 36. You can always pause the video, answer the question, and then look into my suggestions. Now, to find the maximum area of this particular rectangle, what we can do is we can observe very clearly a kind of symmetry here, right? So do you see some symmetry here? If we find the area of just a quarter of this rectangle, which is being highlighted in quadrant 1, you can see, if you maximize this quarter of the rectangle, let's call this as area 1, in that case, you can also get the value for the maximum area of the rectangle, which would be 4 times A1, right? So we can see from the symmetry that the area of rectangle R will be equals to 4 times the area of rectangle 1, which is in quadrant 1. Is that clear to you? So that simplifies our problem, right? Since now we're looking into the x value, which only moves from 0 to this extreme, and we can always find that extreme, correct? And any point here on the ellipse can be represented by x and y. And so we have area of 1 will be x times y. Simple as that. And you can find x varies from what to what. We are given the equation, which is 4x squared plus 9y squared equals to 36. And if y is equal to 0, in that case, what could be the value of x? Well, in that case, we have 4x squared equals to 36, or x squared equals to 36 over 4, which is 9. And so the value of x will be square root of 9, which is positive 3. So this point here is 3. So you can see that the value of x is in between 0 and 3. So we're looking into a restricted domain. So now it's very simple. We just want to find a critical value here for the area. Compare the areas for 0 and 3 and then get our answer. Is that clear to you? Perfect. So I hope you got this strategy. At this stage, you can pause the video, answer the question, and then look into my suggestions. Now, in case you want to learn from me, you can always send an email on the address given. As you know, most of my students are doing extremely well. Some are right there on the top of their class getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Okay, let's continue with the solution of this particular question. So our strategy is absolutely clear. We're only looking into a quarter of this rectangle, which is in quadrant 1. Perfect. And once we find this area, we'll multiply by 4 to get the whole area. So the point on this particular rectangle, which lies on the ellipse, it can be said as x and y. We figure out that this value of x changes from 0 to 3. And the expression given to us is 4x squared plus 9y squared equals to 36. So let's find out what is y in terms of x. So we have 9y squared equals to 36 minus 4x squared. So y squared will be 36 over 9 minus, you can take like this, right? Minus 4x squared. So y squared will be, you can take 4 common, right? Since it is square, I'm not simplifying each term, see? It becomes better if I take 4 common and I get 36 divided by 4 is 9 minus x squared. You see that? And here I get divided by 9. And when you square root, what do you get? Well, when you square root, we're looking for 4 over 9 square root, right? And then within this bracket, we have 9 minus x squared. Makes sense, right? You see? And 4 over 9 is square root of 4 is 2, and that of 9 is 3, right? And we have this square root, 9 minus x squared. And as you know from here, that the value of x is between what? Is between 0 and 3. Of course, right? Within the square root, you cannot have a negative term. And as you can see, we just calculated the x-intercept for the ellipse. Right? The major axis is 3, right? So we have major and minor axis. In this case, the minor axis and the major axis 3, the minor will be 2, right? So this will be 2. So we won't need it. So now we get the value of y in terms of 2 over 9 square root 9 minus x squared. So the area function will be what? So area is x into y if x and y are the coordinate points in general for the vertex of this rectangle on the ellipse. So y being 2 over 9, I can write this as x times, let's say, 2 over 9 square root of 9 minus x squared. Is that clear to you? Perfect. So we have our function, which is a function of x now. So the area 1 is a function of x, as you can see, and can be written as 2 over 9 times x square root of 9 minus x squared. So the first part is absolutely clear. Getting a function in terms of one variable. We chose x to be our variable, and so we have it. Perfect. We also have boundary conditions, right? So now we have to get a critical number, which will be most probably our solution. We'll confirm it by finding the values at 3 points. One is the boundary and the other as critical number. So I hope now the concept is absolutely clear. And so in case you are having difficulty in isolating or finding the function, so that is done for you. Perfect. So this is a good stage for you to pause the video, do the needful, and then check the solution. So I emphasize on your own working and finding the solution, since that is how we learn, right? Okay. So let's move on to the next page. So we have our function, which is area of, we're only considering first triangle, right, as a function of x, and that is 2 over, let's see, square root of 9 was 3, so it's not 2 over 9, that's what I thought. Okay, it's 2 over 3, right? Square root of 9 is 3, right? Right. So 2 over 3x square root 9 minus x squared. 2 over 3x square root 9 minus x square. Perfect. Correct. So let's differentiate with respect to x, right? So we get the area as a function of x, derivative as, so we'll apply the product rule, right? So derivative of x is 1. So we get 2 over 3 as a constant. We can keep it outside. Okay. So derivative of x is 1. So we get square root of 9 minus x squared plus x times derivative of 9 minus x squared. So which is 1 over square root 2. 1 over 2 square root 9 minus x squared times the derivative of inside function, which is minus 2x. Is that clear to you? So we get our derivative. Perfect. Now, to find the critical number, this derivative should be 0, right? So let's simplify it a bit more. Okay, so we are looking into the area of only the first quadrant rectangle as shown here. And the point, as you know, is this particular point, which is xy, where the x value is going from 0 to 3 maximum. Correct? So that is our function. So we can now write down this as equal to 2 over 3. So within this bracket, we can take common denominator of 2 times square root of 9 minus x squared, right? So when you multiply this here, you get what? You get 2 times 9 minus x squared, right? And on this side, or you could have simplified, right? So we'll take 2 later common, minus 2 times x squared, right? This, when you multiply this with that, you get 2 times x squared. I didn't simplify this at this stage, but you should have done. Anyway, so let me just save some space. So I'll write it closer. And now simplify, right? So we do 2 times square root of 9 minus x squared. Correct. Well, this 2 could cancel. So let's cancel this 2, right? Simpler. So we have 9 minus x squared minus x squared within the brackets. Let's rewrite this as 2 over 3. 9 minus x squared becomes 9 minus 2x squared. Minus and minus, right? So the derivative is 2 over 3, 9 minus 2x squared. Perfect. So that's our derivative. Now let's find the critical number. So we'll take it to the next page. Derivative is 2 over 3, 9 minus 2x squared. So the derivative for A1 is 2 over 3, 9 minus 2x squared. Correct? 9 minus 2x squared. So to maximize, we'll equate this to 0. So what are we doing now? We're finding the critical number. So that will be 0 when 9 minus 2x squared equals to 0, or 2x squared equals to 9. X squared is 9 by 2 square root. Right? So x is equals to square root of 9 by 2. So we have the value of x, which is 3 over square root 2. Is that clear to you? So the value of x is 3 over square root 2. Now we had an expression for y also, right? So if I put this value for x, I get the value of y. Perfect. So we can find what y is. So earlier we had isolated what y is. So let's get the value of y, right? So y is 2 over 3 square root 9 minus x square, right? So y is 2 over 3 square root 9 minus x square, correct? So let us substitute the value of x right there to find the value of y. So y equals to 2 over 3 square root of 9 minus x square. The x square value is 9 by 2, right? We could use this value. So that means 9 by 2, right? So 2 by 3 square root 9 by 2, right? And if I do the square root, in that case, 3, 2 over 3 times 3 over 2, correct? Square root. So we get the value of y as 3 and 3 cancel, right? And we get square root of 2. 2 divided by square root 2. So we have the value of x, which is 3 over square root 2, and the value of y as square root 2. Perfect. And now what is the maximum area? We know that x is between 0 and 3. So we'll now find area of this particular rectangle at x equals to 3 over square root 2, at x equals to 0, and at x equals to 3. We'll compare the three areas, and the one which is maximum will be our answer. Perfect. So we do have a critical number, which is x value of 3 over square root 2 and y of square root 2. Perfect. Okay. So what we found was the critical number where x is equal to, let's write down our values, 3 over square root 2 and y square root 2. And we are working in quadrant 1, correct? Where the point is xy, and we know that the value of x can be between 0 and 3. So area is product of these two values, right? So area at the critical number, which is 3 over square root 2, will be what? X times y, right? So will be 3 over square root 2 times square root 2. And that gives you 3 as the area of this particular rectangle. Now if I use 0 or 3 as x value, then clearly area for 0 will be 0, and area when x is equal to 3 will also be equal to, because it is the expression y is 0, right? So x equals to 3 this point, y is 0, right? So it is 3 times 0. And therefore it is also 0. Since the area for the other two boundary conditions 0, we have a maximum area at the critical number, which is 3 over square root 2 square root 2, correct? And what is that maximum area? So let's write down the maximum area now. So the maximum area will be 4 times the area of quadrant 1, right? So the maximum area A will be equals to 4 times area of quadrant 1, which is 4 times the area of quadrant 1 is 3. So we get 12 square. So our answer here is that the maximum area is 12 square units. Is that clear to you? So that is how we are going to solve this particular question. I hope the concept is absolutely clear. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.